Hey, advanced chemistry students, welcome to lesson 2, overreaction prediction. In this lesson, I'm going to go through some reaction prediction for decomposition reactions as well as addition reactions. I've noticed that on this next slide here, unfortunately, there's a note to myself to embed the YouTube video that I want you guys to watch for the 5 types of reactions. We'll catch up with that later. I'm having some issues. Old man issues learning how to use this new program. So here we go. So decomposition reactions, those are reactions where you have a compound that breaks down into 2 or more either compounds or elements, it doesn't matter, but they break down into 2 parts. Yeah. This is usually accomplished through heat, the use of electricity, which is electrolysis, or use of a catalyst in a reaction. So there's going to be, oh man, this is going to come up strange, but that's okay. A compound can be, the first way that we're going to talk about this is breaking out to produce 2 different elements. So in the case of NaCl or sodium chloride, which I have down here, let's get this. Sodium chloride right here. Sodium chloride is going to break down into its 2 parts, sodium and chlorine. When it does, one of those is diatomic. That's the chlorine. That's why it says Cl2. And then the sodium it will break down into. After you break it down, that's when you would go ahead and balance the equation. So if I were starting from scratch on this one, which I'm not unfortunately, but if it was NaCl and I know that I'm going to decompose it and it's going to undergo electrolysis, I would write electricity over the arrow like this. And then it would break down into sodium and it would break down into chlorine. I know that chlorine is diatomic species when it's by itself, so I'm going to give it a 2, and that changes my balancing here. I need a 2 to balance my chlorines and a 2 to balance my sodiums. That's what happened in this equation here. So when it says molten sodium chloride is electrolyzed, you could write a liquid symbol after that sodium chloride, but this is certainly sufficient. So that's one thing that happened. Something else that can happen is a compound may break down to produce an element and a different compound. Hydrogen peroxide, prime example of this. Hydrogen peroxide will break down to make water and oxygen gas. That's actually one of the ones we're going to have you memorize. And then you would go back and balance it as I've done here. So that's another thing that could happen. Now you guys don't have to remember what rule 1 is and what rule 2 is and now rule 3. You just need to know that these things actually happen. Another one, which is rule 3, compound may break down to produce 2 compounds. So carbonates, metallic carbonates are a prime example. They will break down into the compound magnesium oxide and the other compound carbon dioxide. You would go back and balance it after you had predicted those products, but of course a coefficient of 1 is what's needed for this equation in total. So, oh man, this is tragic. So, well, it says it in your notes. Metallic carbonates will break down to produce metallic oxides and carbon dioxide. So this is a metallic carbonate. So a metal with CO3 2- attached to it will produce a metal oxide, whatever that metal is, balanced with those with oxygen as a 2-, and then carbon dioxide as the other product. After you do that, you would go back and balance it. Now in this case, it's already balanced. Also, it says metallic sulfites. Sulfites are SO3 2-. So they always break down to make CO2, do carbonates, and SO3 2- sulfite will always break down to make SO2. So barium sulfite will do something very similar to the previous one. It will make the metal oxide, barium oxide, and it will make sulfur dioxide, or SO2. This also is already balanced. So another rule, metallic chlorates, if you know your polyatomic ions, that's good, ClO3-. When a metal that's bonded to a chlorate breaks down through decomposition, usually when heated, it'll give up the metal chloride and it will give up oxygen gas. So like in this one up here, we would predict the RbCl and the O2, and you would have to go back and balance with the 2s and the 3s to get it right. There on the bottom, the hydrated salts. A hydrated salt is not something we've actually talked about at you guys' level yet, but this is a hydrated salt. It's something that is bound to waters. And so it's really easy to do this. What it is you have a compound that has waters bonded to it, and if you heat it up, you just knock the waters off. The water goes off as water vapor. So what you do essentially is you change that dot, which is a bond symbol, it's bonded to the compound, is it changes to a plus sign. So you just separate the water from the sodium carbonate in this case. Now this is called sodium carbonate monohydrate, meaning that it only has one water. There are lots of them that have more than one water. But no matter what, when you heat it up, it's actually going to knock all the waters off, so you get what's called the anhydrous compound, the Na2CO3, sodium carbonate, and water vapor as a result. So here are a couple other rules. There are ones that I've already mentioned, but, well, the first one's one I've already mentioned that we are going to have you memorize. I know it's a lot, but hydrogen peroxide right here will always decompose into water and oxygen gas. It just does, and you need to remember that. Now, metallic sulfites broke down into metallic oxides and SO2. It is very similar with the hydrogen. This is sulfurous acid. Sulfurous acid will break down so that the oxygen is with the hydrogen making water, and the other product will be sulfur dioxide gas. The exact same thing happens with carbonic acid. It breaks down into water and CO2, as you can see on this one as well. These two right here will be automatically decomposed later when we produce them in double replacement reactions, which we'll discuss later. But those two circled ones you really got to know straight, like right on, because they will be sort of a second step reaction in some future reactions. The practice is on your paper, and we really wanted you to try before you saw the answers. So if you're doing this yourself, you want to go ahead and press pause right now and give those three reactions a shot, and then I'll have the answers come up and show you what they look like in a second. So hit the pause button, give it a shot, and then come back, and I'll show them to you. So hopefully you did pause it, and you're not just letting it. So that's it. Now these have like what rule happened here. I think actually goes through so you can see the answers, but here they are here. This is a metallic carbonate. The rule was metallic carbonates break down to make the metallic oxide and CO2. When I make that metallic oxide, the barium oxide, it's important that I take Ba as its ion, which is Ba2+, and the oxygen, which is O2-. That's how I combine them to get, excuse me, barium oxide. Something very similar here with the nickel 2 chlorate. I would have nickel 2, which is Ni2+, and then what I'm adding to it is the Cl-. When you cross those two, and I hope you guys can see that, when you cross those two, you get NiCl2. After you've predicted those products, that's when you actually go back and balance it. So you have to first predict what your products are going to be before you go and balance them. And then the last one there is a metallic oxide. So this one doesn't have a rule, but it is a compound that will break up into two things. Works very similar to hydrogen peroxide, separates, in this case, into silver and oxygen gas, solid silver and oxygen gas. So that's our decomposition reactions. I know that went kind of quickly. One of the things about the next one, which are addition reactions, is they're sort of the opposite of the decomposition reactions, which makes it, you know, really kind of great, kind of easy. So here it says it's also called synthesis. It can also be called combination or composition reactions, but for the most part, we just call them addition or synthesis. Rarely are they called the other two. So two or more elements will form compounds together. It could also be two or more compounds combined to make this single product or this compound together. So we'll do just a few examples here and then let you guys practice a couple, but a group 1A or a 2A metal will combine with a nonmetal and it makes what we call a salt. So one that you're very familiar with is if you had, and I think we've kind of already covered this in the past, but that's all right. Make sure I've got this correct here. Would be like sodium and chlorine would produce sodium chloride, but you have to use their charges to put them together. So that would be Na plus and Cl minus. It would be NaCl. Then you would go back and balance with your coefficients, a 2 here and a 2 here, which is what has happened there with the lithium and the nitrogen. Lithium is a +1, the nitrogen or nitride would be a 3-. That's why the formula says Li3N. So what we did last unit, what we tested on, a couple days ago, is just paramount. It's very important that you still remember what your ions are. Likely we'll have ion quizzes in the future to make sure you're still doing that. So use the charges to write the formulas of these products. Another one is molecular compounds. If you have nonmetals and nonmetals, carbon's a nonmetal, oxygen is a nonmetal, you squish them together. Okay, 99% of the time, that's good enough for you guys. You take them and you just squish them together. So what I got is carbon and oxygen. I put them together and I get CO2. And you name it carbon dioxide. Pretty stinking easy. And this also happens with acid formation, but we'll talk about the future as well. Two compounds can also combine to make a single product. Now this is a reverse of the metallic oxide, or sulfites breaking down to make SO2 and the metallic oxide. Here we have the reverse of it. It is the same. If sulfur dioxide gas is exposed to the metallic oxide, it produces a sulfite. The same thing will happen with carbon dioxide. If carbon dioxide is combined with a metallic oxide, which is right here, carbon dioxide, metallic oxide, you can't see that in there, but it makes Li2CO3, which would be lithium carbonate. Same thing. And then down here, we have the same thing we did just a second ago. Metallic oxides and sulfur dioxide will produce the metallic sulfite. This is the same rule, but in reverse for what we had for addition reactions. So this one is new. This is not in decomposition reaction, so it's not reversed. But this one right here always gets kids. Metallic oxide and water will make a base. So if you take a metal oxide and you add water to it, or you mix it with water, it actually produces calcium hydroxide. Or metallic oxides and water make metallic hydroxides. If you do take something that's a non-metallic oxide, like carbon dioxide, or like sulfur trioxide or sulfur dioxide, and you add them to water, you do what we said before, you just squish them together. So non-metal, so this is a non-metal compound, a molecular compound, and a non-metal compound, a molecular compound. You squish them together to get your product. So you take that CO2 and that H2O, just combine them all and get H2CO3. That's the way acids are formed. Not the way they're formed, but oftentimes that's how they're formed. It is the reverse of the decomposition of the carbonic acid. Sulfurous acid will do exactly the same. These last three to practice, go ahead and give them a shot, please, and press the pause and try those three. Use somebody next to you if you need to, and then when you're ready, come back and take a look at the answers. So again, hopefully you did that. Okay, here are the answers below. You don't need to know which rule is which. You don't have to know that bases are formed using Rule 3C or Rule 2 is two nonmetals, combining or whatever. Actually, that's a little different. But anyway, you don't need to know which the rules they are. You just need to know that they work. So this would be the metallic oxide and water producing a base. Here I've got hydrogen and chlorine producing hydrochloric acid. And I have carbon dioxide and water. This was straight up the rule we used, producing an acid, which is carbonic acid. So that completes this instruction. I know it was fast. Addition and decomposition reactions just take a little bit of practice. You have one of those sheets, I think it's page 2, in your packet to work on today during the period, or to work on at home if you're doing this at home. Make sure you do them all, and then check your answers online. These are the easiest of the ones we do. I know there's a lot of memorization, but these are some of the easier ones that we do. Okay, I'll see you guys in lesson 3.